Assalamualaikum everyone. Okay, in this video we will continue with the third techniques of integration, that is the trigonometric substitutions. Okay, in the previous video we have learned on how to solve the integration for the rational functions. We have learned how to solve the integration of the trigonometric functions. And now let's see how to solve the integrations by using the trigonometric substitutions. Okay, we have three expressions that involved in this technique. The first one is the square root of e square minus x square. The second one is the square root of e square plus x square. And the third one is the square root of x square minus e square. Basically, this technique, the trigonometric substitutions technique, is used to evaluate the integrals involving radical terms. However, it can also be used to solve the integrals without the radical terms. Okay guys, now let's see the expressions involved in the integrations by using the trigonometric substitution. So basically, this technique is quite similar with the substitution method, but then we need to know what is the things that we want to substitute. Okay, we have three expressions here. Okay, the first one is the expression involving the a square minus x square. The second one, we have the expression involving e square plus x square, and the third one involving the expression of x square minus e square. Okay, for each expression, okay, we will have its own substitution. Okay, so for the first one, for expression e square minus x square, the substitution that we will use here is, we will substitute your x equals to e sine theta. Secondly, for the expression e square plus x square, we will substitute the x equals to e tangent theta. And the third one, we have the expression of x square minus a square. We will substitute your x as a secant theta. Alright, so meaning here you have to identify what is your a and also the x. Alright, sometimes the x is not on the x, it can be anything, 5x, 2x, or anything. Alright, so next we will see the examples on the integration by using trigonometric substitution. Okay guys, let's continue with the examples. We have here the first example is find the integration of x divided by square root of 1 minus x squared dx. Okay, so for this question, we want to evaluate using the trigonometric substitution. Alright, so firstly, let's identify the expression involved in this question. So we have here the expression is 1 minus x squared. Okay, so if we write in a perfect square, 1 minus x squared, it is 1 square minus x squared, which means here your a is 1 and your x is x. Alright, then we will have here your x will be e sine theta. Right, so your a is 1, so you don't have to write the 1, so we just write sine theta. Okay, so next let's see what is the terms that we have in the question. So we have the first one, we have x, and then we also have x squared. So what we can do is we can find the x squared. So the x squared will be sine square theta. Okay, And continue, what is the other terms that we have here? Yes, we also have dx here. Okay, so what we can do is we can differentiate your x with respect to theta. Alright, now we will have your dx d theta equals to, when you differentiate your sign, it will be cos theta. Okay, since we want to substitute dx in the question, so you will write your dx as the subject. That is, dx equals to cos theta d theta. Okay, guys? Alright, let's proceed. We will substitute all the terms that we have here. That is, we have x, we have x squared, and another one we have dx. Okay, so now what will happen with your solution? So the solution now will be the integration of, okay, x will be sine theta divided by the square root of 1 minus, and your x squared is sine squared theta, and your dx now is cos theta d theta. Alright. Okay class, next step is we will modify the functions in your radical function. Okay, so look at here, we have here is, this is your functions in the radical. Okay, so to modify these functions, we will use the formula of identity. That is, the formula identity, okay, we have here is cos squared theta equals to 1 minus sine squared theta. Okay, now when you simplify, now you will have, it is the integration of sine theta divided by square root of cos squared theta, right? And then here we will have cos theta d theta. Okay, next is we will simplify. Okay, simplify, now you will have here, it is so this is square and square root. Okay, now you will have the integration of sine theta over cos theta times cos theta d theta. Okay, remember we want to eliminate radical. Okay, alright, so next we will simplify. So simplify the function, now we will have here, okay, simplify cos, and the remaining functions that we have to integrate now is only sine theta d theta. Okay, next the integration of sine theta, you will have, it is negative cos theta plus c. Okay class? Alright, remember your final answer here must be in terms of x. Okay, but now we have here is in terms of theta. Alright, so now we need to simplify and we need to modify this function from theta into the form of x. So we will use the formula of trigonometric function, that is using the Soh-Cahtois formula. Okay, we have here x is sine theta, right? You have your x is sine theta. Okay, and if we write sine theta as a subject, it will be x over 1. Okay, so we have the formula of trigonometric. Okay, so we have here sine equals to opposite over hypotenuse, cos equals to adjacent over hypotenuse, and we have tangent is opposite over adjacent, right? So here, in meaning here, we have sine theta is x over 1, okay, where your x is the opposite and 1 here is your hypotenuse. Alright, so if you write here, let's say this one is your theta. Okay, your opposite now, this one will be x. Okay. Alright, so this one will be x, and hypotenuse is 1. So your adjacent now will be 1 minus x squared. Okay, basically the terms that we will have here will be the similar terms as in your question. Alright, okay, let's continue. So continue now, we want to find the cos. So look at here, we want to find the cos theta. So from this triangle, we can find the formula of cos theta, which is equals to adjacent. So your adjacent is the square root of 1 minus x squared divided by your hypotenuse is 1. Okay, so now you will get your answer will be, your final answer is negative of the square root of 1 minus x squared plus c. So this is your final answer. Okay class, thank you.